Hello, everybody. Welcome to my lecture on Introduction to Data. Uh, so let's get started. Uh, who's this guy? Edmund Deming. He said this something very uh, important. He said, "In God we trust. All others bring data." So sort of Deming is a very well-known guy when it comes to technology or innovation. He was a statistics person, engineer, management consultant, and sort of he got the National Medal of Technology from President Reagan, and he has also won I think, National Academy of Science Award, and then he was also honored by Japan as he was given the highest award ever given to a non-Japanese uh, for his uh, for his impact on the innovation he had on the manufacturing processes in the Japanese company. But his work is quite well renowned in the work of statistics. Okay, so I'm gonna talk about various uh, issues or various facets about data. So let's the first starting point: where does the data come from for your data analysis or for your business analytics project? The first, you open a analytics SaaS or some other tool, and you manually enter the data in your program, which might be fine if you have, let's say, 20, 30, 50, 70, 100 lines of data. But what if you have uh, uh, if you have 1,000 rows of data? You cannot enter data manually into your program. So it works well for minor simulations or optimization where you have only very short amount of data. The second source is your text files or your Excel file spreadsheet. So you can connect your text files or spreadsheet to SAS Enterprise Miner, actually not Miner, to Guide, and then convert them into SAS tables and then use them in Miner. Then the most important place where you get your data are your databases. Databases are connected to your data warehouse, and sort of those are the places which feed data into all analytics too. And the best part about data coming from a database or a data warehouse is it already is cleaned, has a structure on it, and you can right away start using it. And then your ERP system like SAP or Oracle Business Suite, which connects business processes together in your organization. They are also feeder into your analytics program. But again, ERP systems like SAP or Oracle also have a database working in the background. So you get your data from there. Now, and then finally, you have something new, which is called large text files. Now, what is this large text files? As we have started in this field of big data. I'm sure you might have heard this term, big data, where we are getting a huge volume of data with very high velocity. That means it's getting generated quickly, a billion rows of data within a day. So that's a billion with a B. That's a lot of data. And it takes, if you send a billion rows of data through a database file, or it will take a really long time for us to feed that data inside to a program. So this large text files are really useful when it comes to big data or huge amount of data where you have couple of billion rows of data which needs to be fed into your program. Okay, so these are the places where we are getting our data from. How much data do we need? Uh, Generally, you do something called power analysis, which tells you how much data is needed. So let's say, for example, as I have written here, I am trying to predict y, my dependent variable, which is income. So I'm trying to predict somebody's income y based on their age, education, and ethnicity. So I'm using these three variables, 1, 2, 3. Okay. So I'm trying to predict somebody's income based on those three variables. So generally the rule of thumb is that you need 15 rows of data for each of these variables, independent variables. So right now I have 3. So 15 into 3 is 45. So that's sort of the very simple, easy way to remember that. So if you're trying to predict sales, retail sales of a company, or whatever your model is, you are trying to predict whether a customer is credit worthy or not, and you have 5 or 10 variables which you are using to predict that. So multiply each variable by 15. So that's at the minimum you need to have your results to be statistically significant, or not that your data results are statistically significant, for them to make a statistically significant prediction, if I guess if that's how you want to say it. So that's how much data you need. Then let's look at various categories of data. The first one is, demographic data. So it's called demographic data, which is, let's say, if you're trying to do retail data or sales data or any kind of data about people. So demographic data would be your customers' gender, age, marital status, income, home, education, things like that. So demographic data is very easy to obtain and collect. A lot of marketing companies have that data. You can get it from them. It's not much difficult or expensive to collect this data. What is more difficult to get is attitudinal or behavioral data. So what is attitudinal or behavioral data? Behavioral data is people's action. So people action would be something which people have already done. So for example, if I can get last 3 years of Walmart data of what kind of products people are buying, that will be a behavioral data, because people have, or customers have already paid, or they paid money for it and bought a product. So it's a real action. It's not something where I am collecting survey or anything like that. It's a real data, and that's why companies like Walmart or Costco or CVS, they don't share their retail data with anybody else, because that's a very important data. And behavioral data is real data, because it shows customers action which they really took in the past. Similarly, you have attitudinal data. Attitudinal data is where you ask people that would they like to buy this product. They are not really buying it, but they are telling you their perspective about it, or their intention about it. Or so you can do a survey, or or opinion groups or focus group, where you have 10 people sitting in a room and you show them a movie trailer and you ask them, what do you liked about this, what you didn't like about this. So it's like a attitudinal data. They have really not spent money to buy that product or watch that movie, but they're telling you what they feel about it. So an example of that could be I might have I might do a survey of people in a city and ask them to rate various restaurants in their city. So let's say they have 5 restaurants. I say rate these restaurants on a scale of 0 to 10. So they will do the rating. They're not really going to the restaurant. It's just their perspective or their perception about those restaurants, maybe based on past experience or what they have heard. But on the other hand, if I can collect data, sales data of those 5 restaurants in that city, those will show me the real money people are spending, which is a better reflection of people's action, and is much more truth. And the reason for that is because, people do lie. And I don't want to say it in a mean way or a negative way. Generally, when you do a survey, people tend to answer a survey question in a polite way. They want to answer in the way in which they think the most of the people or the society will answer. So if you stand outside, let's say, a movie theater, and you ask people, do you like that movie which was recently nominated for Oscar? Let's just say, for example, most of the people will say yes, they will like to watch it because it's nominated for Oscar. It looks pretty, movie for the intellectuals or something like that. So they don't want to say, oh no, I don't want to watch that movie. I want to watch the other movie where there's this guy with a big gun, and it's a lot of good action, like John Wick 2, or which I just recently saw. So people are sometimes do not tell their real feelings in a survey. And there's a very good example of that which Netflix experienced. So initially, when Netflix started, they used to ask people to rate various movies, and based on their rating of various movies, they used to recommend them that based on the ratings, this is the kind of movie you might like. So what would happen is that people will rate movies like art documentaries or Oscar nominated or something which is very known for being a very intellectually good movie. Even it might be boring, people under pressure would, or most of the people would mark them higher, and based on that rating, Netflix will recommend a movie to all these people, and nobody would watch the movies which were getting recommended. And Netflix sort of re-examined their algorithm, and they said, is our algorithm wrong? And what they found out was that their algorithm was not wrong. It's just that people were not really rating movies based on what they like or what their taste is, but they were liking the movies based on what society expects them to like. So Netflix then changed their algorithms, and rather than asking people to like various movies on a scale or state their preference, they simply started noting down what movies people were really watching, and then recommended them that you watch these 5 movies based on your past history. We are recommended this other movie or show to you. And then they saw that that worked much better. People were clicking on those new recommended shows which were based on people's past viewing history rather than their survey, their preference. Okay, so now we know where data is coming from, how much data we need, what are the categories of data, what is the preferred data. Behavioral data is the preferred data. That's what we need if we can get it. Now, what are the data sources? Survey data. If you need data, you're launching a new product, you can send a survey to your prospective customers. You can hire a marketing company to do a survey data. You can stand outside Best Buy or some restaurant or mall and collect survey data, mail it to people, things like that. Or you can give them incentive, do the survey, we'll give you $5. Another very important source which has become quite popular nowadays in last few years is your social media data, Facebook, Twitter, Instagram, so on. And the thing with social media data is that we are ourselves sharing our taste, which team we support, which team we are supporting, what brands we like, what coffee place we like. So that's very insightful data for marketing people or for retailers, because I'm saying which team I like, or so they can sell me the sort of the jersey of that team or cap, or which places I want to go for vacation, or which places I'm planning to go travel, things like that. Then third party data, as I mentioned earlier, there are a lot of companies who will do survey data on your behalf, or they have access to real data, which is your behavioral data. Their whole purpose of these companies is to collect the real data and then they sell it. So, you can get finance data, retailing data for, and sometimes it's pretty expensive, 10,000, 20,000 rows of $20,000 you pay for a large chunk of data. That's what the companies do. They collect data and then sell it. Retail data, which is again the real data, which is what CVS, Walmart, Macy's collect. When they have that store card, they are collecting that data. Or when you buy something, that receipt is generated, they keep that. That's the real transaction data. That's what they use to make their prediction about future sales, what's in demand, what seasonal sales, things like that. Of course, databases, which is where most of this data you collect from retail or third party goes and stored. Then the other key thing to remember is difference between self-reported and actual data, which I talked about previously here under this example. Self-reported data is you ask people to rate restaurant on a scale of 1 to 10, or you have access to the real sale data of restaurants in your neighborhood. And that actual data is always much more preferable. We like those. Those are the best one because it shows people real action rather than what people's perception are or what they say they might do. Okay, data source. Now let's look at data types. What kind of data types there are? You can have two types of data. The two broad categories are quantitative data and qualitative data. So your quantitative data is your numerical data, your number data. I have data about 100 people, their height. So that's numerical data. How many pages in a book? Price of product. How much money a people make. So those are your numerical data, which is sort of a measurement of a certain product. Could be price, height, and stuff. Example of quantitative data, and quantitative data is generally called continuous data. This could be, let's say I have a beverage, I'm selling a beverage, so the volume of that beverage or temperature of that beverage are your continuous data, numerical data. Then the other and of course we want numerical data like salary, height, which is something you can use to do data analysis much easily. Then the second category is qualitative data. And qualitative data can further be divided into categorical let me rephrase that. Your qualitative data can be nominal. So nominal is you have your data classes where how those data classes are arranged does not matter. So for example, I am collecting data about my customers, how much money they make, their zip code, phone number, and then their gender. So whether I code your gender, male, female, whether I code male as 0 and female as 1 or male as 1 and female as 0, statistically does not make any difference. Or if I'm asking a question yes and no, whether I code that yes as 1, no as 0, or other way around from a data, because I want data to be numerical so I can do data analysis. I can't do data analysis on M or F. So this sort of the ordering does not matter. Just to show you an example, if in my data I'm classifying milk as 1, a pop as 2, coffee as 3, that's and to do my analysis, or I I classified them in my analysis as pop as 1, milk as 2, or coffee again as 3. Really doesn't make any statistical difference. I can code them whatever way I want. So gender, marital status, yes and 1. You can code as 1 0, 0 1. They both have same meaning. Then you have your ordinal data. Again, your classes of data. But here, the numbers do have meaning. Example, small, medium, large. 1, 2, 3. I rated them as 1, 2, 3. Now here, the numbers have meaning. 3 means is bigger than 1. So in this case, the classes do matter. The numbers do matter. Or, in ordinal data, survey data, rate a restaurant on a scale of 1 to 5. 1 means it's awful, 5 means the best. So if somebody rates a restaurant 1, it's awful restaurant, versus somebody else who rated 5, great. So there the numbers now start having meaning in the ordinal data set. So again, just a reminder, nominal data type, numbering, you can do whatever coding you want, but in ordinal, the numbering does matter. Okay. So now you know various data types. Our first step in any data analysis project, you start with your descriptive statistics. That's what we saw, and this is part of your exploratory analysis. You look at mean, mode, medium. What's the average range of your data set? How much was the standard deviation of your data set? What's the correlation among your data set? And these might sound very simple to do, but that's where we spend most of the time to sort of have an understanding of data. And you want to have a data understanding and business understanding of the data before you can do anything with it. And just to give you an example, if you look at these 1, 2, 3, 4, 5 numbers, right? 1,000, 5,000, 7,000, 8,000, 15,000. The mean is 7,400. Median, the middle is 7,000, and the most frequent is also 7,000. Okay. But if you look at it, most of these numbers have a difference of 4,000 among them, or 2,000. But right here, these two numbers have 8,000, 9, 10, 11, 12, 13, 14, 15, $7,000 difference. So could it be that this is an outlier? If you don't know what outlier is, make sure you read about it. So this might be an outlier, an extreme case scenario. If I remove this from my analysis and then just do mean, median, mode with the other numbers, look, now my mean is 5,000. Earlier it was this much high. This is giving me a different picture. Let me give you an example which I think you can understand and relate with. Let's say I have 15 students in my class, and after you have taken my class, after 5 years, I ask all the 15 students to send me their income. How much money do you make in a year? And I'm hoping most of you are making good money, 100,000, 250,000, 500,000, whatever. But there is somebody in the class, there's one student who make really, really big, and he is making $1 billion a year. Let's just say a new Mark Zuckerberg or Bill Gates or somebody like that. So now I'm adding the data from my students, 15 students. 14 of my students are making anywhere from 100,000 to 250,000, and this one student is making $1 billion. Now I add his income and do an average. The average would be in millions. And then I can say all my students who took my class on average makes $1 million+ because of that one student who's an outlier, who has this extreme scenario, extreme case. But that's sort of a misrepresentation of data. So I want to take out that one record, one outlier, and then I will get the average would be something like 150,000. which I would say is a better representation of the population or the sample I have. What is a population? Let's get to that. So I wanna, going back to that example, I wanna collect data from my past students to see how much money they make after taking my classes after the period of 10 years. And I might have 500 or 1000 students who have taken my class. It will be very difficult for me to go and collect data from this 500 people. What if I take a subset of that, a sample? Same way, I wanna do a survey of what's the average height of people in America. Can I go and collect data of everybody who lives in America and collect data on their height, like 330 million people? Would be very difficult to do. But what if I collect a sample data, which is a subset of the population? And your assumption is, what you want to do is, you want to say is that the subset I've collected represents the whole population. Then it's a good sample size. So, if I want to do a subset of population of the whole US, subset of whole US population, I would like to cover every ethnicity, every region. So I will say, okay, I should collect at least 500 from Northeast, 500 from Northwest, 500 from Midwest, 500 from Southeast, and then 500 from Southwest. So that way I'm covering all the regions, and hopefully I'm covering all the ethnicity. I have at least half the data of women, half of male. My data is equally divided into various age groups. So that way I'm covering the whole population. And that's what you try to do in your sample. So most of the time when you start doing your data analysis, you cannot go and collect the data about the whole population. So you try to get a sample, and you said this, my sample represents, is a good representation of the whole population. And generally when you do random sampling, you fulfill that condition. What is random sampling? Let's say somebody asks me, go and find out what's the most common occupation of people in America. Okay, so what I end up doing, I end up going and asking all my friends, all the people I know, all the people in my workplace. And then I said, oh, the most common occupation is teaching, professors, because that's the people in my workforce. I did not do random sampling. I just did something called convenient sampling. I just collected data from what was convenient from me. That's a real term, convenient sampling. That would be not be a good representation of the whole population. So again, I should do random sampling. I should do sampling in various different offices, different states, so that I'm not limiting myself to a convenient sample, but a random sample. Okay. How do you test whether your sample represents the whole data set? You can look at the distribution of your data set. So for example, you create this bell curve, this distribution, and that's your mean. And let's say what you want to say is that 68% of your data is within -1 or +1 of your standard deviation of your mean. 95% of data is here, and then 99% of data is right there. So again, just to emphasize, you want to have this bell curve in your data set. And this bell curve, again, it's a big topic, please read about it. And this bell curve says that the majority of the data is concentrated near the average of your data set. Okay, and so this is your normal distribution, which is what we like. This is your left skewed, that most of your data is on the higher side. That means your data has a bias, left skewed, right skewed. So this could be axis could be your this side could be your age and income, something like that. So as we say, as your age increases until a certain level, let's say this is 50, 55, your income also rises, and after 55, since you're getting close to retirement or you might retire, your income goes down. But then we collected this data which says that the highest income people have is above 60, 65. This says around 40, 45. Here it's highest kurtosis, I hope I pronounce it rightly. Here all our data set is in the center. We don't have much data set on the edges. And here all the data set is on the edges. There's nothing much in the average. And that's what this is showing up. This is what you want in it. This is what a good distribution should be in a data set, that majority of the data is around the average and less towards as outliers. Skewness, you don't want this. This says that we have some bias in the data set, and same thing here. So that was my sort of introduction about the data. And I would, since this is not a statistical course, I will recommend that if you do not have much background in statistics, which you don't really need to do data analysis, but it's good to have it, please read a little bit about regression, correlation, distributions, bell curve, qualitative data, quantitative data. So please read it, brush up a little bit about some of these topics. Go to Wikipedia and read about them so that you have a little bit understanding of what the data is before you start analyzing it.